Hello, viewers. In today's session, we are going to discuss another important problem from Dirac delta function. And here we have to evaluate this integral involving the delta function. Here the limits are minus pi by 2 to pi, and we have x square plus pi times cos square x and delta of minus pi x dx. So to evaluate this integral, we have to make use of one important property of Dirac delta function. So here let us call this integral as I, and here we'll make this important property of delta function, which says that delta of say ax is given by a 1 over absolute value of a and delta of x, where a is not equal to 0. So we have delta of ax is equal to 1 over mod of a and delta x. So let us apply this property to this delta function. So here we have delta of minus pi x, and if we compare these two expressions, then the value of a is minus pi. So delta of minus pi x can be written as 1 over mod of minus pi and delta of x, and mod of minus pi is simply pi. So we have 1 over pi and delta of x. So we can now write this integral as I minus pi by 2 to pi. We have x square plus pi cos square x, and here we have 1 over pi and delta of x dx. So let us now take 1 over pi outside the integral. We have minus pi by 2 to pi and x square plus pi cos square x, and here we have delta x. So delta x can be written as delta x minus 0, and here we have dx. So now to evaluate this integral, we have to make use of the definition of delta function, which says that if we have the integral, say from minus infinity to infinity, and we have a function f of x, which is associated with the delta function, and here we have delta of x minus a dx, then the value of this integral is equal to the value of this function f of x at this point, that is x is equal to a. So here we have f of a, because we know that the delta function is 0 everywhere except at the point a, right? So here we have the peak of the Dirac delta function, and Dirac delta function has value only at this point, and except at this point the delta function is 0 everywhere, right? So here we can now take this function as f of x. So f of x is x square plus pi, and here we have cos square x, right? And here the domain over which we have to integrate is from minus pi by 2 to pi, and we can see that this point, that is a, that is a is equal to 0, it lies within this interval, that is minus pi by 2 to pi, right? Okay, so here the value of this integral is equal to simply f of a. So we have I is equal to 1 over pi, because we have this factor 1 over pi, and here we have f of 0, right? Now we can find out the value of f of 0 by simply taking x is equal to 0 in this function. So we have 0 square plus pi, and then we have cos square 0. So we have 1 over pi. This is simply 0 plus pi, that is pi, and cos of 0 is 1. So we have 1 square. Now here pi and pi get cancelled, so we are simply left with 1. 1 square is 1. So the value of this integral is equal to 1.